Hi, in this video we're going to look at the sampling distribution and the community distribution function of the mean of where the mean of the total scores obtained by 3 spins on this spinner. Okay, let's just read through the question first. The spinner in the diagram is spun and the number it points to is recorded, so it can land on 1, 3, 4 or 6. Write down the table of the probability distribution. Calculate the mean and the standard deviation of this distribution. The spinner is spun 3 times and the score x is the total score. Find the sampling distribution and the community distribution function of the means x bar and find the probability that the mean score is more than 5. Okay, so let s be the random variable the number the spinner points to. We're just talking after one spin. The distribution of this is, well, it can land on a 1, 3, 4 or 6. So we make a table. S can be 1, 3, 4 or 6. The probability that S is equal to S for a 1 will be, there are 8 segments, 8 sectors here, so it'll be 1 out of 8. A 3 will be 2 out of 8, which is 1 out of 4. A 4 will be 2 out of 8, and the 6 will be 3 out of 8. Notice if you add up those probabilities that you get 1. It's a good little check for you. Okay, next we've got to calculate the mean and the standard deviation of this distribution. So writing out the distribution again. So the mean of a distribution, E of x, the formula is sigma all x for x times probability that x is equal to x. So we're going to do all s in this case, so s times the probability s is equal to s, so we would do 1 times 1/8 plus 3 times a quarter plus 4 times a quarter plus 6 times 3/8, and that gives me 4.125 or 4/1/8. We need to do e of x squared in order to find the variance. So e of x squared is e sigma of all x for x squared times the probability that x is equal to x. So e of s squared will be 1 squared times 1/8 plus 3 squared times 1/4 plus 4 times 1/4, 4 squared times 1/4 plus 6 squared times 3/8, and that gives me 19.875 or 19 7/8. The variance of a random variable is e of x squared minus the mean squared. This is the mean. So it's going to be the variance of s will be 19.875 minus 4.125 squared, which gives me 183 over 64. Now we asked to find the standard deviation. So the standard deviation is the square root of the variance of x. And so the standard deviation of the variable s will be the square root of 183 over 64, which is 1.6909, which is 1.6923 singular figures. Right, now we have to find the distribution of the sample mean if we spin this, we're finding the mean of the total score if we spin it 3 times. So let x be the random variable, the total after 3 spins. Now here comes the difficult bit, because you now have to list all the samples. So the first one would be, we get 1, 1, 1. You need to do this in some sort of logical manner, making sure that you don't miss any out. So get 1, 1, 3. Now 1, 1, 3 can happen 3 different ways. You can get 1, 3, 1 and 3, 1, 1. Similar with 1, 1, 4. 1, 1, 6 can happen 3 different ways. 1, 3, 3 can happen 3 different ways. So 1, 4, 4 can happen 3 different ways as well. So you can see some sort of logic in the way that I'm sort of listing the samples here. 1, 6, 6, again 3 different ways, and then I'm going to start with 3, 3, 3, and then I'm going to do 3, 3, 4. I don't need to do with 1 because they're all covered in here. So that happens 3 different ways, and then I'm going to do 3, 4, 4. That can happen 3 different ways. And then I'm going to get to 3, 3, 6. That can happen 3 different ways. And then I'm going to do 3, 6, 6, and that can happen 3 different ways. So you can see some sort of logic now. Now I'm going to do the ones with 4, but I don't have to worry about the ones with 3 and 1 because I've already done them. So we've got 446, 464, 644, and then 466 and 646, 664. We've done all the ones with 6 except 666. And then you have to remember that you might get 3 different things. So you can have 1, 3, 4. Now there are 6 different ways that can happen, and I'm not going to list them. The reason why there are 6 different ways, there are 3 ways for the first number, so 3 ways you can put that number. 2 ways that you can put that number, then only 1 for the third number. Therefore there's 3 times 2 times 1, 6 ways of arranging those numbers. So I'm going to multiply that one by 6, and then do 6 times 1, 3, 6. So missing out the 4 this time, and then missing out the 3. I'm going to have 1, 4, 6, and then I'm going to miss out the 1 and get 3, 4, 6. Each of those can happen 6 different ways. Right, we're interested in the mean of each of these. So the mean of the first one is 1. The mean of the next one is 1 plus 1 plus 3 is 5. 5 divided by 3 is 1 2/3. Here we get 1 plus 1 plus 4, which is 6. 6, that's 2. And then the next one will be 7 over 3, which is 2 2/3, and then so on. So you've got to be careful and work out all these means by each one there. They're written in red. Okay, at this stage, it's probably good if you take a screenshot of this particular screen before proceeding with the next part of the videos, because you'll need to refer to it. You need to be particularly careful because some of them happen twice. So one probability of getting 1 happens just one way, but let's take one here, like 2 2/3. There's 2 different ways that can happen. That sequence of events and that sequence of events. You need to be particularly careful. So just going there, if we've got the standard probability of getting each one 1. So working out the probabilities, again, you need to be very, very careful that you don't miss anything out for the mean of each variable. So the probability that the mean is equal to 1, well, that can only just happen one way. I can go back to that can just happen one way. Okay, and the probability of getting a 1 is 1/8, so it's 1/8 cubed, which is 1 over 512. The probability that the mean is 1 2/3, going back to this, is going to be 3 of 1/8 to the squared times 1/4, but it happens 3 different ways. This is why you need to be able to refer back to that. Okay, the probability that 2 1/3, okay, going back to that, 2 1/3, which is this, 2 1/3 is this one here. Okay, again, it's 3 different ways. 1/8 times 1/4 squared, 3 times 3. Right, next one, the probability of 2 2/3. So you're going to be 3 times 1/8 squared times 3/8, plus 6 times 1/8 times 1/4 times 1/4, which is 33 over 512. So just look at that. 2 2/3 is this one. So it's going to be 1/8 squared times 3/8 times 3, because there's 3 different ways, and then there's another one down here, so it's going to be 6 times 1/8 times 1/4 times 1/4, and that's how that works. So, and what you need to do is go through all those probabilities and work them all out. I'm not going to explain each one, but this is why it's a good idea to take a screenshot of the previous slide. So working them all out, and I must admit this took me quite some time to do as well, but you can work them all out. Just do it in a logical manner. Good test of your probability. And it'll stop when we get to 6, because the last thing you can get, highest you can get is 666, which is 18. Right, okay. Obviously, one way to check that you got this right is to take all these probabilities, add them up, and check that you get 1. So check that the sum of all the probabilities is equal to 1 for all x. Now you've got to write them out in a distribution. So write the distribution of the means. So x and take on all these values. 1 and 2 first, 2, 1 first, 2 and 3 8, right up to 6. Writing each of the probabilities. Now we have got different denominators here. It might be more useful to write them out using the same denominator like I've done here. Okay, and it's a good way then to, if you add up all the numerators and get 512 out of 512, you know you've got it right. Because this bit's very important, that the probability of x is that the mean is equal to some value x must be equal to 1 for all values of x. Now to get the commutative distribution function, which is quite useful in probabilities, if you write those all out again, same values of x, sometimes this can be written as f of capital F of x, or probability of x being less than or equal to some value of x. So probability that x is less than 1 or equal to 1 is 1 over 5/12, and then you just add the next two together. So 1 plus 6 gives you 7, 7 plus 6 gives you 13, and then so on all the way through. Up to this one, and then when you add in 27 to this one, you're going to get 512 over 512, which is 1, which is what was expected. So just write it out again. Speed it up a little bit. Right, now we can use the commutative distribution table to answer the problem, or you could use the other one as well, as long as you know how the table works. We want the probability that the mean was greater than 5. That means we must consider the probability greater or equal to 5 and 1/3. So we're going to consider this part of the table here. So to get that, we do 1 minus all of these. Okay, so 1 minus just this one here. All of these is the sum to all of these. So it's going to be 1 minus 431 over 512, which is 81 over 512. Okay, this has been a video to show you how to find the sampling distribution and the commutative distribution function from free spins of a particular spinner. I hope you've understood the video, and I hope you've understood, and I thank you for watching the video.